So we are told figure 4 shows the sketch of the curve with the equation x squared minus 2xy plus 3y squared equals 50. Part A is asking us to show that dy by dx equals y minus x over 3y minus x for 4 marks. Okay? The first thing I'm going to do is I'm just going to highlight our original equation. Okay, so which is x squared minus 2xy plus 3y squared equals 50. So when we are being asked to differentiate something like this, what we are being asked to do is to do implicit differentiation. Implicit. And this is a way of differentiating equations with both x and y in them, where you can't just rearrange to get y equals something, as we have here. Okay? So what I'm going to do to begin with is I'm going to start by writing our original equation. So we're going to start with x squared minus 2xy plus 3y squared equals 50. What I'm going to do to start off with is I'm only going to differentiate terms with just x with respect to x, okay? So what that means is we will end up with 2x minus d by dx of 2xy plus d by dx of 3y squared, which equals, and then the derivative of 50 with respect to x is going to be 0, okay? So all I've done is differentiated terms with just an x in them with respect to x. The next step is we're going to differentiate terms with just a y in it. And the rule we're going to use to do this is going to be the chain rule. So what we're going to say is, if you have d by dx of a function in terms of y, as we have, this will be the derivative of our y function, so this is going to be d by dy of f of y, times dy by dx. Okay, and this just comes from the chain rule. So what we will end up with is 2x minus d by dx of 2xy. Remember, we're not going to do anything to this part because it's in terms of both x and y. Okay, and then what we're going to do is we're going to add, so d by dy of fy. So in our case, fy is 3y squared. So the derivative of that is going to be 6y. So we're going to do plus 6y, and then times dy by dx like this, which equals 0. Okay? Now, to differentiate 2xy with respect to x, what we're going to do is we're going to use our product rule. And just as a recap, the product rule says that if you have d by dx of, say, ux, so a function in terms of u, times vy, so a function in terms of y, this equals ux times the derivative of y, okay, the y function, plus your function in terms of y times the derivative of your function in terms of x, okay? So what we need to do first is we need to find ux, vy, and by extent the derivative of ux and the derivative of vy, okay? So what I'm going to do is I'm going to say that ux, so ux equals 2x and vy equals y. From here, what I'm going to do is I'm going to find the derivative of ux, which is just going to be 2, and the derivative of vy is just going to be dy by dx. Then what we know by the product rule is to get our, derivative, we cross multiply like this, okay, and then we add the results together, all right? So what we can say is, I'm just going to combine this all into a final thing, so we will have 2x minus, so we said d by dx of 2xy, so it's going to be ux times vy, so it's going to be minus, and then in brackets, 2x times dy by dx plus, and then 2y, so this, okay, plus, and then we have our 6y dy by dx, which equals 0. Now that's all that's left to do is some rearranging, and we're going to take our dy by dx out and rearrange for that, okay? So what I'm going to do is I'm going to say this becomes 2x minus, and then 2x times dy by dx minus 2y. So all I've done is taken this minus and multiplied it by both of our terms, plus 6y dy by dx. This equals 0. Okay. Now the next step is to take out dy by dx as a factor. So we're going to have dy by dx times, and then 6y minus 2x equals, and then 2y minus 2x. Now what I've done here is this 6y and this minus 2x, I've just rearranged it to put the 6y forward to keep the minus 2x after it. And then I've taken dy by dx out as a factor. And then on the other side, I've moved minus 2y plus 2x to the other side to get 2y minus 2x. Okay? From here, we can say that dy by dx equals 2y minus 2x over 6y minus 2x. Now notice we can divide everything by 2 to simplify it. So we say therefore dy by dx equals y minus x over 3y minus x. And what we can do is we just check our final form. So it was y minus x over 3y minus x, and we have y minus x over 3y minus x. So that's all good, and we can write as required, like that. And then we are done with our question. So this question is worth 4 marks. Your first mark comes from either getting that the derivative of 3y squared is 6y times dy by dx, so as we have here, or for correctly differentiating 2xy and getting that it is 2x times dy by dx plus 2y as we have here. So doing either of those correctly will get you your first mark. So we've done the first step correctly, so we'll just put a tick by this little section here. Okay. Your second mark comes from differentiating all the terms correctly and getting them sort of in this line here. Okay. So representing them this way gets you your second mark. Your third mark comes from rearranging and taking dy by dx out as a factor, so as we have on this line. So this is worth your third mark. And then your final mark comes from doing the necessary algebraic simplifications to get dy by dx equals y minus x over 3y minus x as required. So we are told the curve is used to model the shape of a cycle track with both x and y measured in kilometers. The points P and Q represent points that are furthest west and furthest east of the origin O, as shown in figure 4. So figure 4, see P and Q. It says using part A, part B is asking us to find the exact coordinates of the point P for 5 marks. So I'm just going to highlight some key points. I'm going to highlight that the points P and Q are furthest west and furthest east. Okay. I'm going to highlight we need to use part A, and I'm going to highlight we need to find the exact coordinates of the point P. So now we have this information, let's get started. So the way we're going to go about solving this is we're first going to look at our vertical tangents P and Q, okay? At P and Q, the tangents are vertical lines, and vertical lines have a change in x of 0, okay? So this means our gradient function is going to be some change in y divided by 0. And the problem when you divide by 0 is, mathematically you can't do it. It doesn't make sense, okay? But what we can say is we can say the tangent or the gradient at P and Q approaches infinity, okay? Because this is infinitely steep, okay? So you can say, what I'm going to write is I'm going to say at P and Q, dy by dx approaches infinity, okay? And the whole thing for saying that is you can't say dy by dx equals infinity because infinity isn't a number. But what you can say is you can say it approaches infinity. So that sort of solves our problem, okay? Now, if we use the fact that dy by dx approaches infinity, we can actually use this to figure out what the next step would be, okay? So, as a rule, if you have a over b approaches infinity, what this means is it means that b equals 0, okay? So this is something you kind of have to sort of see for yourself, because if you have y minus x over 3y minus x approaches infinity, and you rearrange that, what you end up with is 3y minus x equals 0, because that's the only way you can have that, okay? So anything over 0 approaches infinity, and if y minus x over 3y minus x approaches infinity, it means 3y minus x equals 0, okay? So from here, what we can say is, therefore, 3y minus x equals 0. Okay? So what I'm going to do next is I'm going to rearrange 3y minus x to just put it in terms of x. Okay? So we're going to say 3y minus x equals 0, therefore x equals 3y. And what I'm going to do is I'm going to plug x equals 3y into our equation for our curve. Okay? So what I'm going to say is this implies that 3y squared minus 2 times 3y times y plus again 3y squared equals 50. So all I've done is I've put in 3y into here and 3y into here, okay, using that x equals 3y. So what we can do now is we can expand this, solve this as a normal equation and get our answer. Okay, so 3y squared is going to be 9y squared minus, so we have 2 times 3y times y, so this is going to be minus 6y squared, and then plus 3y squared equals 50. 9 minus 6 is 3. 3 plus 3 is 6. So we're going to end up with 6y squared equals 50. And then dividing both sides by 2, we get 3y squared equals 25. And y squared equals 25 over 3. Okay? Y equals plus or minus 5 over root 3, and rationalizing our denominator we get y equals plus or minus 5 root 3 over 3. Okay? But, so we've got two solutions here, but the point only has one solution because that's the definition of a single point. Now if we come to our question, we need to find the exact coordinates of point P. If we look, point P here has a negative y value and a negative x value. So from here, what we can say is, since point P has a negative y value, okay, we can say the y coordinate of P equals minus 5 root 3 over 3. Okay? The final step is to find our x coordinate, and we know that x equals 3y. So all we need to do is do 3 times, and then brackets minus 5 root 3 over 3, and say this equals minus 5 root 3. Alright? Finish it off by writing it nicely and neatly. We say, therefore, point P equals minus 5 root 3, comma, and then minus 5 root 3 over 3. So this question is worth 5 marks. Your first mark comes from understanding that at P and Q dy by dx approaches infinity, and therefore 3y minus x equals 0. Your second mark comes from solving either y equals 1 over 3x and x squared minus 2xy plus 3y squared equals 50 simultaneously, or doing x equals 3y and x squared minus 2xy plus 3y squared equals 50 simultaneously. So that's what we have done, and so that gets us our second mark. So just somewhere where the examiner can see you've attempted to do it gets you your second mark. Your third mark comes from either getting x equals plus or minus 5 root 3 or y equals plus or minus 5 root 3 over 3. So if you solved it in terms of x, you would get the first answer. If you solved it in terms of y, you would get as we have gotten here. So that's that answer. Your fourth mark comes from using your earlier equation, so that x equals 3y or y equals 1 over 3x to get the other value. So if you worked out x, the fourth mark comes from finding y, and if you worked out y, your fourth mark comes from finding x. So we've worked out x here, so we get that mark, and then your fifth mark comes from giving your final point in the correct form, so both of them have negatives. Part C has asked us to explain briefly how to find the coordinates of the point that is furthest north of the origin. Okay, and bear in mind, we do not need to carry out any calculation for this question, so I'm just going to highlight that. I'm going to highlight that we need to find the point furthest north. So the point furthest north is somewhere about here, okay? And if you were to draw a tangent, what you would notice, sort of, is this tangent is 0. So the gradient of the tangent is 0, okay? So it's going to be a horizontal line. What that means is that you would end up with dy by dx equals 0, because the gradient of the tangent is 0. So what this means is y minus x over 3y minus x equals 0. And then, by extent, y minus x equals 0. Okay? Because you multiply both sides by 3y minus x, and then you just get y minus x equals 0. So we have this equation which you've come out from using the fact that the tangent has a gradient of 0. So all you need to do is, so rearranging this one actually gets us y equals x. So all you need to do is solve y equals x, and our original equation, which is x squared minus 2xy plus 3y squared equals 50, simultaneously, okay? And then from here, you would choose a positive solution, because if we look here, our furthest north point has positive x and positive y. So, and choose positive solution, like that. And this question is worth 1 mark, and you get 1 mark for writing exactly what I have written here.